In this video, I'm going to talk about rationalizing the denominator. That means getting the square root out of the denominator, or getting a square root out of the denominator. We're not allowed to have square roots in the denominator. So, for example, number 1, I have square root of 2 over 3 square roots of 3. This square root of 3 has to go. I have to get rid of it. I can't just cross it out. I have to cancel it out somehow. The way I cancel out a square root is by squaring the square root, which means multiplying by the square root of what I have already. The square root of 3, that would cancel it out because what I would have is the square root of 3 squared if I multiplied by the square root of 3. And the square root and the square cancel each other out, and I'm left with 3. So I can multiply by the square root of 3 in the bottom. If I do that in the bottom, I have to do that in the top. Keep the fraction balanced, keep it the same. Don't change the value. I'm multiplying by a giant 1. When I do that, I'm going to end up with the square root of 2 times the square root of 3, which is the square root of 6 in the numerator. Square roots in the numerator is okay. And then in the denominator, I have that 3 that I originally had, which was okay, and I didn't have to change, times the square root of 3 squared, which I already said the square root and the square cancel each other out. I'm left with 3. I have the square root of 16 over 9. Oh, 16, no. The square root of 6 over 9. And this is my answer. For number 2, I have 2 square root of 2 over 4 minus the square root of 6. If I see an expression with addition or subtraction in the denominator that has a square root, still need to get rid of the square root, not allowed to have it there. I'm going to multiply by what we call the conjugate of the base. So the conjugate of the base would be the same first term, same last term, but instead of subtracting, I'm going to be doing the opposite, adding. If it was adding originally, I would change it to subtraction. I just changed the sign in between the two terms. This makes it the difference of 2 squares, which is going to, when I square this thing, it's going to cancel it out. If I multiplied by the square root of something, this first term here would become a square root that I would have in the bottom, and that would be a problem. So I need to multiply by something that's going to not change this to be a square root, but get rid of this square root. And so I multiply by the conjugate. This is a giant 1. Again, I'm not changing the value of the fraction. I'm multiplying by the same thing in the top and the bottom. I like to, off to the side, separate my top and bottom. So I do 2 square root of 2 times 4 plus the square root of 6 for the top. I am distributing that 2 square root of 2 to both terms. I have 8 square roots of 2 plus 2 square root of 12. I can take out a square root of 4 here. So I have the square root of 4 times the square root of 3 times 2 plus 8 square roots of 2. And I'll end up with simplified 8 square roots of 2 plus 2 times, this is 2, which is 4 square roots of 3. So this is the top of my fraction. And then the bottom of my fraction is going to be 4 minus the square root of 6 times 4 plus the square root of 6. This is the difference of 2 squares. So I'm taking the first term and squaring it and subtracting this is going to give me the difference of 2 squares. So I'm taking the first term and squaring it, and then taking the second term and squaring it and subtracting that. And when I do that, I get 16 minus 6, which is 10. So 10 is in the bottom. And then I just put the 2 things together. So I have 8 square root of 2 plus 4 square roots of 3 all over 10. I'm going to take out a 2 in the top and the bottom because every term shares a 2 in common. So I'm going to take out a 2 in the top, and that gives me 2 times 4 square root of 2 plus 2 square root of 3 all over, I take out a 2 in the bottom. I have 2 times 5 gives me 10, and these 2's cancel each other out, and I'm left with simplified 4 square roots of 2 plus 2 square roots of 3 all over 5, and this is my answer. For the last problem, I have 3 over 2 cubed root of 16. Now, I want to get rid of this cubed root. So in order to do that, I'm going to need something that is a perfect cube inside. And so what I need to do is I need to break down what's inside already. 16 breaks down into 4 times 4. And if I broke it down further, I would see 2 times 2. I don't want to break it down any further. I have 2 4s that are being multiplied. I'm going to need 1 more 4 being multiplied to make that 4 cubed, so that when I take the cubed root and the cube are going to cancel each other out. So I'm multiplying by 1 more 4. The 2 doesn't matter. I don't have to change it. I just need to get rid of this. And if I multiply in the bottom by the cubed root of 4, I need to do that in the top as well. Multiplying again by a giant 1, not changing the value of anything. I'm going to end up with 3 times the cubed root of 4 all over, and then I have 2, the cubed root of 4 cubed, which gives me 3 cubed root of 4 all over 2 times 4, which my final answer is 3 cubed root of 4 all over 8. And that's my final answer.